But honestly, these two people are wonderful people as a person, but also great professionals.
Nice to meet
I truly love them. I truly love working beside them, and we have done wonderful things together. And I'm very happy to see them here.
Thank you.
And this is yours, guys. Now, all right?
Thank you, Daniel.
Yeah.
No pressure. I like
Shine.
it like that. All right. Hi, everybody. So today we'll talk to you about how we had all the nice high-level theory, how we align our data with the emerging AI demands. I want to introduce my colleague, Tayeb. Tayeb works as an enterprise architect. So he's really doing the gap between the business strategy and how do we bring that into an envisioned target architecture.
And I present my colleague Alex. He is the architect, solution architect. We design end-to-end data and AI solution that are aligned with both business goal and enterprise architecture. Now let me tell you a little about BDC, the company we work with. So BDC is a development bank for Canadian entrepreneurs. We support more than 100,000 business across a country in every industry and at every level of growth by giving them access to finance and advice. We committed to business more than $57 billion, and these clients are very satisfied with our services and product. And we do that in three manners. The first one is financing, is primarily by term loan. The second one is capital investment. BDC is in Canada is the largest and more active and the VC venture capital investor in Canada. And also with advisory services, we help them to make a better strategic decision that how we help our client. And Alex will present what we'll cover today at this agenda.
All right, so it all starts with use case, vision. So today we're going to show you how this architecture came into life. We will show you that it's important to have these strong data foundation and that we have good governance around our data. And we will be by showing you some use case and reasoning why we went from the good old BI, business intelligence, into that modern platform that can handle AI agents.
So we start with this slide. You probably see it in the evolution of enterprise architecture in world. In the years 80 and 90, we are talking more about client-server infrastructure and so on. And in beginning in 2000, we talk more about service-oriented architecture. At this time, we talk about data architecture or process, data services or process services. Data services is just to get data, and process to do something there. And at this time, we talk about is it a noun or verb to implement this protocol, and we use API, and then there is a protocol like REST or SOAP, and there is many after. When the cloud comes, we talk about DevOps or DevSecOps for continued integration, continued development. And the last years with the Gen AI, because the AI, as you know, with machine learning, NLP, and so on, is here for decades. But with Gen AI, is democratizing the access and the usage of AI. And we are talking, lastly, with the AI agent. But here I want to make the parallel between service-oriented architecture and the AI agent. When we are talking about services, we talk to retrieve data as data service or doing something with process services. So in the first one, we use any SQL view or any method in any language. And in the second one, there is some work in StoreProc or so on. The parallel with the agent now, in the both we have one thing to do, retrieve information or doing something for agent. But the difference is, in services, we human, we create the code behind these services. But now with agent, what the agent have to do, it's communication within LLM and in AI thing. That's one difference. The second one, when we work with SOA, it's more structured data that we use. But now with agent, it's not only structured data, but it's structured or unstructured, like videos and text and so on. The third thing between the two, in the SOA is a static model. When we define API or define a view and so on, it's a definition, we code it. If there is change, we have to change our code. But now it's more dynamic. So when we call agent, it depends what plan we'll have and how we execute this plan. For that, the protocol changed. Before we use more API, now we use more, for example, MCP to make discovery and call the appropriate method. So there is a parallel there, because for this more than about 26 years, we have a lot of experience, a lot of data, a lot of some. So this agent or AI can learn from all this experience to do what we can do today. Next. So here we present what we started many years ago for our data platform. We have a principle in architecture, shift left. All that we can do in the source, we do it in the source, not after on data platform or warehousing or so on. Where we get the data, is it from external sources or internal from our application? And then what we want them, every application is responsible for some data. So what's happened inside each application is the internal kitchen. But outside, we have to expose that in standard format. And because we are a bank, we use BIAN standards. BIAN is for Banking Industry Architecture Network. But the endpoint is depend. It's event or API or views or file. And then we use that in our platform with 3 layers. We get this raw data. After that, we can standardize, integrate data, and historization of this data. We create new data. It's more by aggregation and so on. If there is business calculation, we do it outside with calculator. And to avoid having data warehouse in one side and data lake in other side, like a Lambda architecture, what we use is this virtual layer on our data on data lake, and that's what we call a lake house. And all that we expose all these services based on this data, and we have the catalog. The catalog, we indicate the origin of data, the lineage behind, and all the definition and literacy behind that. So in beginning, when we start that, it's for BI, so it's more for reporting, dashboarding, having a cube in the multi-dimensional format to do some report or analysis. After that, we give access, depend on the role. It's a role-based access control. It depends on the role of each to do some exploration. Sometimes we didn't need all the integration or work, just discover what's in this data to work with. There is many applications, but the need is not real data communication between all the application on left, but it's more integrated data, historical data, and so on. So the platform is for that. And before the Gen AI, with the machine learning, with Daniel team, there is many models in regression or classification model that was created. So it's based on data platform. When LLM came, so all the data are already integrated. And when we start the first agent, the work is more easier because the data is already in one place instead of going to many systems and trying to find how to make integration with all this data. And the calculation is outside the data platform because we don't want, for example, when you calculate the risk measure, to do it in the data platform in ETL. It will be very complicated too, but outside, the business have to manipulate this configuration, doing some scenarios, and so on. And when there is the right result to share with other departments, then we send it back to the data platform, and we expose it to be used by others. So that's what we call a unified data platform. we expose these data services. And the feature store, it's more for Daniel team, for machine learning, how we learn what we create as a new feature from this data. For example, if you are analyzing fraud, you are not interested in all historical addresses, but is there change or not? So all this new data that we create, that's part of this feature store. And Alex will explain how we implement or design this architecture at VDC.
All right, thank you, Tayeb. So we'll go a little bit lower, but not too much in the detail, but just to give you some idea of some division, how it's being put in place. So we have, as you know, multiple sources. We've talked about structured data, files, database, event, API, its structure. We know already the format of the data, but we can also have unstructured, and there's a lot of benefit to get that unstructured. So unstructured could be images, PDFs, video, sounds, whatever. There's always data in there, so we want to get that. We will, from one, go into the transformation. So the transformation is the medallion architecture. We use Lakehouse with medallion architecture. It's perfect with the Olympic Games, good timing. So the bronze is the third place, is the first place where we put the data. So the data comes in, we stage it, we just append. We put the data in there. It's no business in there, no transformation. It's our way up to the cloud. This is where it could get messy if people consume there. This is more a layer to bring the data. You don't have to turn that into a swamp. The second layer is the silver. This is where we start creating trust in our data. So we will do standardization. You will have a naming convention in there. You will have date format, for example. The format will be all respected. So there's some cleanup being started in there. And that's a layer, silver, where we also take the advantage to put our data by domain. So we referred to Beyond before. I invite you to consult that. It's banking industry framework, so that way we could define the data, for example, customer, loan, opportunity, and right away we start toward decoupling from the source system. The third layer, it's the gold one. So the silver will feed the gold layer. This is where our use case comes in. So you will have aggregation, calculator that sends score. You will have ML outputs in there, fact and dimension is in there and everything. It's a third layer. This is really where the business outcomes comes in. The third part is behind all of that, we use storage. So we decide with this platform to be scalable. So we have open format storage in the cloud. CSV is an open format, Avro. We use Parquet, and we're benefiting of Parquet to do Delta Lake tables. And that's open format. It's column-based, so the retrieval of the information is way faster that way. The second thing that we have in there is scalability. So we have the compute. No more hardware, infrastructure. Yes, but kind of invisible. You just move a switch. You have more CPU for more processing of data, or perhaps you need more GPU for a model that consumes a lot of memory, for example. And sometimes we see serverless. We could have some use case with serverless compute. The third part is the open source. So structured query language. That's to run query. We all know that for sure. But we also have the platform where we could write some programming language like Python. Once you unlock Python, you could use a wide variety of library for different tasks possible. We could then be using Spark for, again, multi-parallel and processing the data in high volume and speed. And benefits of all the machine learning flow to monitor your ML model, for example, have more observability inside the platform. So all of this is scalable, portable, and brings the platform agnostic of a vendor. We can take tools that fit in different vendors. So if we go a little bit more in the platform itself, we have the source. We heard about data contract. It's important to define a data contract so that way there's a handshake with the source system. You know what kind of data you're receiving. You could know the frequency of the refresh of your data and adjust your pipeline accordingly. We have two types of ingestion. We have the batch, good old batch that reads a complete list of data, for example, that could be scheduled with your enterprise scheduler. Or we have a listener for event, where we could go real time, near real time. Your source system publish a change. Hey, new customer created. You just grab this information or call the API to retrieve it, depending on your model. Then this will go in the middle in the storage. You have the different medallion I just talked about. So it will, based on your use case, flow in through that tunnel. Using our transformation engine, our AI and ML enrichment in there. All of this will be used by the servicing layer. So you have other API that needs data. You have code-based queries. You have user that runs exploration, had a query on top of your data. So with this platform, we bring this all possible. And obviously, to the completely right, it's a small player, but it's getting bigger. It's the AI agent. So the data is not scattered everywhere. You have that governed in your platform. And with the last piece of the architecture vision is the foundation, governance, data quality, obviously your code that's being Git deployed, and all of this to bring maturity to your platform. We'll go a little bit detail on the governance part. Yep.
And to implement all of that, we, as a bank, what strategy we choose between offensive and defensive one. If we see the defensive one is based more on data security, privacy, quality, and so on. And we find in this area more like hospital, defense, and all this specific area. In other side, for retail, for example, it's more offensive because there is a product, service to look for client and so on, and the sensitive data are limited. Banking, we are in middle between the two. We have privacy that is very important and relevant. Like retail is more there to be heavily regulated and to have to respect all that. But at the same time, you have to find more clients, more product, more services, and to expose them. So we are in middle. If we go next slide, and I use the same metaphor, but in the soccer or soccer game, when I use it first time, that, hey, why you use the soccer and not hockey? I can answer to that for two reasons. Because in soccer there is a free line. There is defense, midfield, and the offense one. That's the first reason. And the second one, because on the field there is 11 players in each team, and in the bench there is more than 11 waiting for. So player for us is more the capabilities. And in the soccer games, if you master or control the midfield, you dictate the path of the match. Why? Because the midfield, it could help in defense and in offense, depend on the case. I will choose some example here, for example. If I start with data life cycle, is very relevant to know where data came from. Is it from external, internal? What we'll do after? Is it created new data from this data? And after that, it will be historized or archived or deleted. So it's like us, the human, is the same behavior. For example, I am a migrant here to Canada many years ago. Alex is born here in Canada, but we work together. We are not married, but for others, for example, can get kids and so on, and after studying, so preparation, then working, then retirement, and then you know where we go after retirement. So it's the same thing here with the data, so you have to see it in the same manner. In the defense line, we see privacy and so on, so we have the data to be secure, to be privacy by design. For example, if we have all the data for our client in one place with an ID specific to the company, BDC, for example, BDC ID, and only this ID will go everywhere, but the sensitive data, keep it at one place. But in the middle, for example, when we see data quality, for example, if the quality is good, then we can play more offensive to expose, to do. But if there is some problem with the data quality, this middle go to the defense, working at the source system to prepare, to improve the quality of the data. If I take second example, sustainable data. If the data came from application that's well designed and well quality there, that's good. We can play with these sources in offensive. But if many of our data came from Excel file and Access file and all this stuff and the quality is not there, it's better to be in defensive and work on getting sustainable source. And for the offensive, or the AI play a big role there for insight, for client, and so on. Next.
So the governance, I don't want to name any vendor, but governance starts with, in our lakehouse, the way we see it is we have interconnectivity between these three components. We have our data catalog that will do the assessment and sensitivity of the data based on metadata. It will be able to discover the lineage, where the data came from, where it's going. We will be able to define the assets. Where are they? Description, each column, tables. We will assign a data owner also for accesses. Who will allow me to grant access to the data? This information metadata is really important to be pretty enriched in partnership with SME system. And this will be transferred to the unified data platform where we will manage that through tagging. We will be able to know who can access what, where is the data, and how it is used, obviously with observability and monitoring around that. We also have a big player, the data quality platform, that will also observe the data and pinpoint problems on the data to apply modification. Obviously, the platform is after the fact, so the data quality platform will also inform the source system. Hey, you're sending us data that we have to clean and this and that. So there's a big round circle around these three. Yeah, you see the activity of the round. So the governance is really important to be kept for a modern tool.
And when it came time to implement the EA agent we have for enterprise. We start for enterprise, it's for our employees to get this experience, and if there is some mistake we can correct, is inside, is not client facing, and also for our developer for the coding and how we use it. So we start with the simple one, EA agent for information retrieval, or the first agent that we develop to retrieve information from different systems, to summarize, to prepare meeting, and so on. So it's more like when you compare it with the data services, so it's to get the data, so there is no action. And we start with our employees, so it's internal, human in the loop, and he can control that. We don't start directly with the client if there is problem, so it's not easier to fix it, and you have to explain how. And now we start the first the case for the client, but irretrievable information. When we master this first level, we start from the second level, taking action. And even for taking action, in beginning, just sending an email or do something with the low risk, not like accept a loan or evaluate a loan and so on. So we are getting step by step from the simple one to the intermediate. And when we create this agent, we create them in as agent as service. We use the protocol that we know as MCP and to retrieve data. And when it came time to EA agentic, at least we can reuse many of these agents, but use this protocol, MCP, for example, to retrieve information or to call tools and so on. So we are prepared for that. And Alex will show you some example that we did in a few minutes.
Yep, so nice thing, nice theory, everything. We have all foundation solids and everything. This is one of the use case. So we have virtual business center. The center, like it says, is virtual. There's business development leads in there, the person who gives the loan, that have around 500 customer in their portfolio. So imagine the difficulty to maintain a good discussion with the client and be informed where are they at, where are you working at, and stuff like that. So what we decide to do is to use the data services to get an idea of who is the customer, all his information, loan, finances, and also with machine learning scoring, give a score of a likelihood to repeat business. So we're enhancing the data we have already, put that all together, and we integrate that into their call center. So that way when they log in, even though they're 500 person to contact or to keep in touch, here's a top 10 that you should be talking to for XYZ reason. That's one of our use case. So it increases productivity, obviously, and the repeat business. The second one is the digital companion. So the companion is there. It helps. What happened is we have these, now we're not in the virtual center, we're in business physical center. We have possibility of turnover of employee. That way you lose the context or the non-said discussion with the customer. So you're contacting your customer, he has to re-explain your business, you're missing some context, some information. So the BDL, we're struggling also to get information from different systems. So what we did is by the help of our data platform, we were able to supply this information. Again, enrich with the machine learning information for perhaps some advisory services recommendation. And we also add some market trend and industry information. Plus, in this case, we use generative AI to summarize conversation. So we had all past email, contact, calls logged in the system and summarization in there. So we wrap all that. There's a nice conversational chat interface. They're talking, asking question, follow-up question also. So that way they can enhance their discussion. Again, thumbs up, thumbs down. We're gathering this information to enhance also the quality of the data we return. The last one is the legal assistant. So we had a use case where we're receiving some risk mitigation document for other lenders. And we're talking about a deal of securities, for example, who has ownership on what and this and that between co-jointer of banks. So we received document from email. They had to go in this, read who it is, understand what they're asking. So instead, we gave them an interface, an experience layer where they could upload this document. It founds with LLM from the text who it is, what is he asking for. Turn around again, same data services that we already have, not another silo of data, same thing. Bring all that together and bring it to a point where you have everything in front of your eyes to discuss, so you can respond fast. It could be furthermore automated, but in the 3 use case that we have here, we always kept the human in the loop for now. We're not in the staircase to the top completely. We're at the beginning. It gives you information, but the deal is like anybody here, when we're talking, we're always challenge what AI says and ignore what doesn't make sense. Give feedback to the application. That way, algorithm will readjust the output and stuff like that. So I think we came from a strategy, an envisioned target, and we demonstrate today how we brought that all together in 30 minutes, but it took a little bit more time than that. I assure you. Thank you very much. Do we take questions, or do we still have time for questions?
There's, I don't know. We have 2 seconds. Let's take one question.
Just one? I have 5. I'm just kidding. So in the second slide, I think it's the modularization our data. You were talking about step from multi-source to the second one, which is transformation.
Yes.
And you mentioned there's a raw data, and you take all the data to the raw data. There's no possible way for you to lose certain information, especially when it's structured data like REST, or data when you use MCP or agents or LangChain in the process from a knowledge perspective to feed for your LLM?
Well, we bring that into the layers just to keep the data in there. This is pipeline, ingestion pipeline. So we don't lose data in there. We know from where it came, where it goes, all of that. But what you're referring to with the LangChain and everything, then is when we build model or consume around it. So we have an MCP server in front of our platform, and you have in the middle your client, MCP client, your orchestration in there. So it's all in there that the LangChain is played and look at the different source. So no, there's no data lost as it is. We're kind of just like if you're adding a connection to your agent.
That's it.
All right. Well, if there's no more questions, thanks for not
Okay.
stealing this.
Thank you.
Leave to the expectations. Thank you for building all that for my team.
No